Hi, this is 10.2 part 3. Just a word of warning, you will absolutely need a calculator for this. So make sure you have your calculator. Pause me if you have to go run and get it because it's going to require you to graph. And what we're going to do is we're going to graph several points. So some of the values we will know and some of them we won't. So it's really important that you get it. So anyways, there's a chart on the top of the page, and we have to be familiar with this chart because if we know what we're graphing beforehand, we can get a general census of what the graph is going to look like. And it's going to require you to analyze values in front of cosine or sine and the value that's being added or subtracted to it. So if we look at the first example, this is a cardioid, and r equals a plus or minus a cosine theta, where a is greater than 0. Notice that the values in front of cosine and the value that's being added to it are the same. Another one we could have is r equals a plus or minus a sine theta. Once again, notice that these values are the same value. And it makes a graph. So this is what a cardioid, and I might be saying it incorrectly, but that's what it looks like. The next one is a Limacon with an inner loop. So r equals a plus or minus b cosine theta, or r equals a plus or minus b sine theta, where a is a bigger value than b. That's what it says on those conditions here. So notice that a and b are not the same. And if a is bigger than b, then we have the Limacon without the inner loop. So it kind of looks like a cardioid, but it's moved from the center. Let's look at the Limacon with an inner loop. This time around, once again, we have a and b here, but if we look at the a and b, they are of different values, and b is bigger than a. So if b is bigger than a, you get the little loop-de-loop inside, okay? Let's look at the next ones. The Limacon, and once again, guys, if I'm pronouncing this wrong, I'm sorry. But at any rate, this is where r is squared in the equation, and we have a squared value for a. Cosine is of a double angle, or we could have r squared equals a squared sine of the double angle. And what we get here is what I like to call a helicopter. So it looks like a helicopter's propeller, like an old one, I should say. The next one is a rose with 3 petals. So if we look here, we have a sine of 3 theta, or a cosine of 3 theta, where a is a value greater than 0. And this time around, we get 3 petals. And finally, we can get a rose with 4 petals. So what happens there is r equals a sine of the double angle, or r equals a cosine of the double angle. Guys, it's important to know the difference between this and, let me do a check mark here, and the Limacon. Because the Limacon has r squared equals a squared, whereas a rose is just r equals a. So that's how to tell the difference between the two. Otherwise, they look very similar because they're both dealing with the double angle. Okay, so let's go ahead and check out the next page. We're going to have to actually do some work here. And because I don't want to make this video horribly long, the first one I will go through in detail, and then for the next 2 examples after this, you are going to have to fill the chart out yourself. So let's go ahead and look at this. It says identify and graph the polar equation. R equals 6 minus 7 cosine theta. Actually, it doesn't, and I skipped a problem on accident. The problem that is underneath the first part of this page, the charts, is identify and graph the polar equation r equals 3 plus 3 cosine theta. Sorry about that. So we're going to do this one first because we're going to do them in order. If we notice here, the values are the same. The value that's added to the coefficient in front of cosine theta is the same. So we can say that a equals 3, right? And if we look at that chart, and I'm going to bounce back there. If we look at the chart, we know it's a cardioid because a plus or minus a cosine theta fits the bill. So we know that our shape is going to look something like this. The question is, how is it oriented? Is it oriented on the y-axis? Is it oriented on the x-axis? I don't know without graphing it. So we know at least it's a cardioid. So let's go ahead and write that down. And how do I graph this? What I'm going to do is I am going to make a chart. So my chart is going to contain a column for theta because that's my angles. There's going to be a column for r because that's my equation. In this case, r equals 3 plus 3 cosine theta. And I'm going to have a column that reads r comma theta because that is my coordinate points. Remember, I have to plot these. So if you don't know how to plot a polar coordinate, go back and watch 10.1 first, okay? So the other thing I need to do is I need to complete this graph here because it basically just has quadrant 1 taken care of, 0 through 90 degrees. So what I'm going to do is I'm going to go ahead and put in the other values. So I'm going to put in 120 here, I'm going to put in 150, 180, and then 180 plus 30 is 210, 210 plus 30 is 240, then we have 270 already in there, 270 plus 30 is 300, and 300 plus 30 is 330. I'm also going to put 360 here. Now, if you want your equation really, really nice and exact, you can put in the 45-degree angles. That's fine. But just for this sake, and because I know what the equation pretty much looks like, I'm only going to, well, you know what? Let's put the 45s in. So if you want it really exact, go ahead and put those in. So this is 135 in quadrant 2. In between 210 and 240 is 225. And then 315. So it's just like graphing a line. The more exact you want to be, the more angles you put in there. Okay? So let's go ahead and write all this down. So the first one I'm going to look at is 0 degrees. Then I'm going to find 30 degrees, 45, 60, 90, 120, 135, what's next? 150, 180, 210, 225, 240, and I'm going to make the rest of the chart over here, okay, because I ran out of room. So next is going to be 270, 300, 315, yikes, and then 330 and 360. Okay, I'm going to go ahead. I'll put 330 right at the bottom. I know it's getting a little there, but 360, by the way, is going to be the same as 0. So those are our values. Let's go ahead with it and go through here. So I'm going to do the first one. R equals 3 plus 3 cosine at 0 degrees. So this is when you need your calculator. I hope that you know that cosine at 0 degrees is 1. So we get 3 plus 3, which equals 6. But you can type it in your calculator. So this becomes my radius equals 6 and theta equals 0. Okay, so my coordinate point is 6, 0. And I'm going to plot these after I do this. 30 degrees. R equals 3 plus 3 cosine at 30 degrees. Plug that in your calculator and you'll see when I plug in 3 plus 3 cosine at 30 degrees, I get 5.6. And I'm rounding up to 1 decimal place after the decimal. So I get 5.6, 30 degrees. 45 degrees, once again, R equals 3 plus 3 cosine of 45 degrees. Plug that into your calculator and you get 5.1, 45 degrees. By the way, if you're not getting the values that I am, check to see if your mode is in degrees, because if it's not, you won't get the same values as what I'm getting. So now we're going to plug in 3 plus 3 cosine of 60 degrees. And when we plug that in, we get 4.5, 60 degrees. Okay, 90 degrees. R equals 3 plus 3 cosine of 90 degrees. And when we do that, we get 3, 90 degrees. 120. 3 plus 3 cosine of 120 degrees will give me R. And what does R equal? R equals 1.5, 120 degrees. 135. 3 plus 3 cosine of 135. When I plug that in, I get the 0.9, comma, 135. Moving on to 150, I get 3 plus 3 cosine of 150 degrees. And when I plug that in, I get 0.4, comma, 150 degrees. 180, plug and chug. 3 plus 3 cosine of 180 degrees. That equals 0. So we get 0, comma, 180 degrees. Okay, so let's go ahead and move on. And 210, I plug that in. I get 3 plus 3 cosine of 210. And when I plug that in, I get 0.4. So 0.4, comma, 210 degrees. Plugging in 225, 3 plus 3 cosine of 225. What's that equal? That equals 0.9, comma, 225. 240 is 3 plus 3 cosine of 240 degrees. And when I plug that in, I get 1.5, comma, 240. Okay. And I want you to notice something. Notice the values around 180 or the pole. Notice that they're repeating, right? Like 0.4, 0.4. At 135, it's 0.9. At 225, it's 0.9. At 120, it's 1.5. At 240, it's 1.25, or 1.5, excuse me. So as we go around the pole, we're getting the same exact values, which means we have symmetry. So let's go ahead and finish this out. 273 plus, I'm using the wrong tool, plus 3 cosine of 270. That equals 3. 3, comma, 270. So does that make sense? Yes, because if we look at 90 degrees, the same value is 3. So I can predict that 300 is going to be the same as 60 degrees. But let's check. 3 plus 3 cosine of 300 degrees. What does that equal? It equals 4.5. Okay, continue on. 3 plus 3 cosine of 315. Plug that in, and we get 5.6, which makes sense because look at 30 degrees, same value. Or sorry, yeah, 30 degrees. And then finally, plugging in 3 plus 3 cosine of 330. Let's see what we get. When we plug it in, we get, and I have to apologize to you, I actually got 5.1 for this one and 5.6 for this one. That's what I did there. Okay, so those are all your values. Your next step is to actually plot them. And we're going to do this. So at 0 degrees, I get 60. So let's look at the biggest value I have at 6. So let's change this to 2, 4, 6, 8. So I just changed the radians, or the radius of this polar graph. Okay, so I changed the radius to 2, 4, 6, and 8. I'm going to plot the points. At 0 degrees, it's 60. So there's that point. At 30 degrees, it's 5.6. So at 30 degrees, 5.6 is about here. Well, let's say about right in there. Okay, at 45 degrees, it's 5.1. At 60 degrees, it's 4.5. At 90 degrees, it is 3. At 120 degrees, it's 1.5. Okay, that's about right there. Okay. At 135, it is 0.9. So that's clear in here. I'm trying to get this exact. And at 150, it's 0.4. It's getting closer and closer. 180, it finally sinks down to 0. So far on our graph, we have something that looks like this. Okay? So this is the graph so far. So let's see what the rest of it looks like. 210 is going to be 0.4. 225 is 0.9. And 240 is 1.5. Okay. And then At 270, we have the value of 3. And so on and so forth. So 300 is 4.5. And I put that in the wrong place. 315 is 5.1. And 330 is 5.6. Okay, so here we go. And, we're going to get a shape that looks like this. So it's symmetrical. And by the way, it is not a heart. It's more curvy right in here. Okay, so this is what your graph looks like. It shouldn't be sharp on this end. Okay, so, and that's what we expected to see. So that's a cardioid. All right, so the next examples, I just put the top of the page before each and every one, so ignore this for the next example. The next example says 2 minus sine theta. So this time around, let's skip the 45 degrees and just stick to 30, 60, 90. So theta, and I'm going to have you make your own chart. Theta is going to be 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210, 240, 270, 300, 330, and 360. Okay, so those are your theta values that I want you to use. And then you're going to use r equals 2 sine theta this time around, and it should be a minus sign in there. So r equals 2 minus sine theta. And then you want your coordinates, r comma theta. So I want you to plug those all in and then get your points. And by the way, I'm checking your notes, so I will know if you didn't do this step. So please make sure that you write every single thing in there and actually do it by hand, and don't just rely on hearing me. Actually use your calculator, okay? So pause me and do that, and then unpause me, and I'll have the chart done, and we're going to do the graph as well. Okay, so this is what I got in my chart, so go ahead and compare your answers. You once again pause me, and then I want you to graph each of these points along this graph. And by the way, there's 2 units between each 30 degrees. So see 0, 2 units 30, 2 units 60, 2 units 90. So go ahead and please graph this and then check your graph against mine. Okay, so here's what my graph looks like. So hopefully yours looks like mine, and also check out that we have symmetry around the 90 degree axis, right? The 90 degrees value for the angle. And if you look at the 90 degree angle here, we can see that the values, the R values are symmetrical. So I just wanted to point that out again. I think same thing happens around 270. We have symmetry around these values here. So we know we have symmetry, and by the way, we could have checked that using the rules of symmetry that we learned in 10.2 part 2. Okay, so the next one is identify and graph the polar equation, and we have 6 minus 7 cosine theta. So this time around, I know that A equals 6, and B equals 7. So what's bigger? So B is greater than A. So if I look at the graph, and we can quickly go back to a clean one here. If I look at this and say that B is greater than A, I have a limacon with an inner loop. Sorry, and I thought that was a highlighter. There we go. So it's a limacon with an inner loop. So we know that my graph is going to look like this. Okay, so how is it oriented? I don't know. And where it's positioned, I don't know. The only way to do that is to actually graph it. So here is the problem again. R equals 6 minus 7 cosine theta. I'm going to have you graph this one entirely on your own. And you know, I will post a picture of what I got on, what's it called, on Canvas there after you guys turn it in. So after the due date, I will show you what this page looks like. So please make sure, you know, use 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. Use those values to graph this out. And I do want to warn you, you will get negative radius on a couple of the values. So if you have a negative radius, remember you have to plot the positive point, but then move it 180 degrees. And if you don't know how to do that, please rewatch 10.1. Okay? So once again, this one I want you to do on your own, and I want to see you plot the points, figure out what they are, and so I know that you know what you're doing. Okay, so let's go back to the next one. Identify and graph the polar equation. In my math lab, unfortunately, they have, you know, pick the graph. So we're just going to do this really quick. Notice that we don't have a number plus something cosine or plus something sine, right? So everything's kind of jammed together. But we do have an A equals 5, which is not a squared value, right? Okay, so it's not a squared value, and we have a double angle. So if I look at my choices, and let's go back here, I do not have a squared value, and R is not squared, but I have a double angle. So it looks like I have a rose with 4 petals, okay? So I know that the graph is going to look like the one I just checkmarked. So if that's the case, then the answer to this can only be A, because if we look at B and C, those don't match up with what we're given. Okay, so there's the graph again. So let's look at the next example. Identify and graph the polar equation. 8 is not a squared value, and neither is R. R is not squared as well. And then we have 5 theta. Okay, so what can this be? Well, I know it's not B because B would require A to be squared and R to be squared. And I have 5 theta here. So I'm guessing that I have 5 loops, because usually the thetas correspond to that if they're odd. So if that's the case, I have something that looks like a sand dollar. All right, so let's check out the next one. Identify and graph. Oh, this time around we have R squared, and A is 64. If A is 64, I can rewrite 64 as 8 squared. So I have a square term for R and a square term for A. So therefore, I have the helicopter. Remember I told you the Limacon, and we can look at that here. See how R is squared? Oops, keep on wanting to highlight. So R is squared and A is squared. So we have the Limacon. So the answer to this has to be B. Okay, so that's how you can identify and figure those out. And this is the end of 10.2. All right, and once again, I will be checking that one page that I did not write out for you to make sure that you know how to graph polar equations.